Most businesses are trying to make money, and one of the things they need to do is maximize their revenue. Not talking about profit or loss, but revenue is just how much money total you're bringing in. So if you sell things, it's going to be the number of items that you sell times the price per item will tell you how much money you're bringing in. Now, this is a very simple scenario. So let's say that you run a canoe rental business on a small lake. You currently charge $12 per canoe and you average 36 rentals a day. But then you're doing some reading, and an industry journal says that for every 50-cent increase in your rental price, the average business can expect to lose 2 rentals a day. So you decide to use this information to try to maximize your income. So what changes should you make? Okay, so the first thing that jumps out at me is we are making price adjustments. So I'm going to let that be my variable. I'm going to say that X is the number of price changes. And I'm going to write a revenue function. And I'm going to call this R of X for my revenue function. And I'm going to have 2 sets of parentheses here with expressions in each. One where it's about the price and the quantity. So I'll put the price first, really doesn't matter. So typically, they rent canoes for $12 per day. And when they do, they rent a quantity of 36 rentals per day. So normally 12 times 36, they're bringing in $432 a day. Not profit, just revenue. But going off of the suggestion of this industry magazine, they're saying, for every 50-cent increase. So if the price goes up, so I'm going to add 50, if it goes up 50 cents, but that would only be one time, I'm going to put an X here for the number of times it's changing. So plus 50 cents X, I can expect to lose 2 rentals. So the quantity, how many I'm renting, is going to go down by 2, but 2 for every price change, so minus 2X. Here is my function. And now I can use this to find all kinds of information about what the business should do. You can graph it and take a look at it. I know that the parabola is going to open upside down because if I were to multiply this together, I would have a negative A value. Since my goal is to maximize my income, if I want to maximize it, I know that this is occurring at the vertex. So I need to find the vertex of this function. To do this algebraically, I can do it several ways. I choose to put this in standard form. So I distribute to multiply the 2 binomials together, and I get what's on the screen here, and I need to combine my like terms. If I put this in standard form, I see that I do have that negative A value of negative x squared minus 6x plus 432. So if I want to maximize my revenue, I need to find the vertex, which would be at negative b over 2a. So when I do that, I get negative 3 for the x value of my vertex, and I would have to plug that in to the original function. Doesn't matter whether you plug it in here or into this line, but you need to find r of negative 3. So if I toss that in my calculator, I get 441. So my vertex is negative 3, 441. All right, so let's talk about what this means. We defined X as the number of price changes, all right? So what's this telling me? Since it's negative, it's telling me, you know what? You better not be increasing your price. You better be dropping your price, not by $3, but 3 times. And when you do, what's our Y? Well, Y is R of X. So we need to drop it 3 times, which means 50 cents each time. We will drop it $1.50 then, so we need to sell these for $10.50. A more algebraic way of thinking this through is if you take the price portion of your original function and you just plug it into the price portion, which would be 12 plus 0.50 times negative 3 to see what you should be selling it for, and that's going to be $10.50 should be the cost for canoe rental. So $10.50 per rental will give you a maximum revenue of, well, we already have our max revenue, that's your Y value, of $441.